Hello cadets, I'm giving you a little bit of a video to show you how to type up your work. I've provided a template for you in the Dropbox. The beginning of your work, so I want your names at top, so you'll erase your names and you'll put your own name. So I'm going to demo this live. And then here in this section, you have to respond to the critiques that you received during your IPR. So in the beginning, when you respond to a critique, you should always thank your critiquer. So you always start off with how grateful you are for the time and energy someone spent to look over your work. And then you follow that up with answers to the critique. So if you got several critiques that were similar, like in this critique, it was a critique on lack of model description. So we got several of them that were like that. And so we combined it all as one response. So you can do that. So that way you're not taking in and bulleting out every single critique that you're given. And if there's something that you're not in agreement with, so you could say 2 here. Let's just make something up. I'm making this up, so it has nothing to do with anything. Lack of model data to validate model, and you don't agree with this critique. You say we were unable to address this critique within the scope of this project, despite the value of the feedback. This is due to insufficient time to collect data as part of the project. So you're letting the reviewer know why you didn't put in a feedback to something. So I'll have a copy of all the feedback that you were given as part of your IPR, and then I'll go and look at how you addressed it and how you combined it. So you don't want to use up too much space because you're limited to 4 pages. And you can have appendices in your project write-up, and I'm going to mention that in a second. Then you have 4 tasks. In each task, how I would like you to split this up is in the following way. Not just like you have to do it because you're going to be graded on it. So follow the format where you first explain the objectives. So exploring second order system, I'm going to make something up here. This is not what your project is about. I'm just typing something to show you live how this works. So this is usually 1 or 2 sentences max. You just are explaining what it is you're trying to do. In this task, we needed solved second order systems. I'm just making something up. Okay, so just I'm making something up. I don't think this is to do with your project. Under methods, this is where you actually show the math of what you did. So I'm just making something up here. Describe pendulum motion, which is not what you're doing. Always use equation editor in your work. Starting to go into LaTeX there for a second. So that's not fed it into there. Here you don't put what you found, you're just explaining the process of how you came to your results. So here you should, methods are dry as dust. You're just explaining what it is you did. So everything's in past tense in the methods section. And on you go. You describe all the things that you did. Then the results section is what you found. A good idea for the results section is to take some key figures. You don't want to take all of them because you're going to make a lot of figures in each of these sections. So you'll take a key figure that explains a lot of information in that key figure of what you found and put that key figure in. So I do not have Mathematica on here, but we can just take a random figure. So let me show you a trick. You're trying to save some space. So what you do is you go to Insert, Text Box, put a text box in here. Don't worry that it's not positioned right. What you do is go to Wrap Text and put Tight. And what that'll do is it'll put that text box in line with your text, and it won't take up more space. So I could slide it over here, and then I could put a picture in here. So let's put a picture in here. Has nothing to do with anything. I'm just going to pull something from somewhere. Let's take this one. It looks bad. It's too tiny, so let's make this a little bigger. And then we'll put in that picture. There we go. And then you'll put a caption for that figure. As you'll know notice in the details of the project, you're supposed to have figure captions, but you're always supposed to have figure captions. Figure 1, label it, the Blond-Altman plots describing the validity of the second order differential equations. Additional plots are available in the appendix. So it's really important. People's eyes go to the figures right away, that your figure caption be detailed, it'd be very clear. This picture is pretty small. I can make it bigger. So we can make it resize it so that it's a little bit bigger. So you can see that I have actually made a title for my figure. And I've also made headers for the figure. This is not the best figure to pick because it's not a good figure, but you can see that the axes are labeled clearly. In fact, let me blow that picture up because it's also important to know that the axes should be labeled not as X and Y, but with the words of what they mean. So look at the titles. These are actual models. This is actually work I'm doing with Captain Plucker here. So you can see right here, I've put units on my axes. Let's pull it even bigger. Hey, let's do better than this. Let's leave this in, and let's just take a look at that figure. So you can look at an example of a good figure. These aren't good. These were for me. This one's good. So you can see body temperature in degrees. That's being measured in degrees. Time elapsed, hours. The units are on there. The title is on there. So I can look at this figure and in a few minutes I can see what your results are. In fact, in most papers in the rest of the world other than math, people's eyes go to the figures and they just read the figures to figure out what's going on. So you can do, this is like a terrible figure to put here, so let me put a different figure. So now you can see the units. Kilograms, so you can see what's being measured. You can also put in tables. So you can put the table by screenshotting something in a table and putting it in as a figure. The problem is if you want to change anything on that table, then you can't edit it, or you can just copy and paste the Excel table into one of these text boxes. And I am going to ask you to do it this way because it looks professional and nice. Okay, so you have that. That's what goes in the results is your figures, and you describe it in words. From, I'm just making something up that doesn't match anything, from our simulations of the second order differential equations, we saw there is a trend in the error. Figure 1. So this is how you explain it. And you let the reader know you're supposed to go to figure 1 for proof. And we always boldface the figures so that, again, it's for people who don't pay attention. You just want to go and be able to find what you need to find. The raw data appears in table 1. So you also want to do the same to tables. So here you don't elaborate on the results. It's a little bit dry as well. You just explain the bare minimum of what, it's dispassionate. There's no passion in this part. Where does the passion come from? So now this is right here, the discussion. Our finding, we found, in the discussion you put a little summary first of what we found. We found that planetary motion is hard to predict. However, our models do a decent job. So here you put a summary first. The first paragraph's always the summary. First few sentences is summary. Then you interpret those results. And then you extrapolate a little bit. So we're hypothesizing now. This may mean that the laws don't hold in space, or we have numerical error in our simulations. There could be possible explanations that we found some surprising thing. And then at the very end, one sentence. What do I conclude from it? What's the take-home point from what I just did? So it could be that our findings suggest that space travel to another planet may not be feasible. So you have a one-liner here that's the take-home point for your reader. So this is basically how you do each section. You put in the sections very organized. You know where to put everything, and I know where to look for it. And I know when something's missing, because if the discussion section's not there, or the conclusion section's not there, I know that you just ran something in Mathematica and didn't put those two pieces in there. Those are really important. So don't forget to put them in. Now, at the end of this, this document, you have additional guidance on content where the developers of the project have given you information here. I think that if you actually put in everything into the template the way I just described, this is a no-brainer. You don't want to bullet things out. You do want to write in prose. It is science. There's no passion in the methods and the results. There might be some passion in the discussion. Tone it down. Don't have too much passion there either. and the conclusion. So if you put all those pieces in, you'll satisfy the end part, but you might want to look this over just to make sure. I'm actually a little bit more strict on how I want these figures to be placed and how they should look. And so I've described this pretty carefully out here. If you have any questions of format, and if you finish it early and you want me to look it over, I'm very happy to look it over. I'm looking for a very good product. Thank you.